Well, hello everyone. So today's topic is why your Postgres tuning guide might be wrong and what to do about it. Let's start. A little bit about myself. My name is Mohsin Ejaz. I've been in the Postgres space for close to 2 decades now. Most of my time has been with Enterprise DB. I am mainly, in the DevOps, QA, and release management side of things. I specialize in CI/CD, automation, and database benchmarking. For the past 2 years, I've been part of DBTune, where I serve as a senior DevOps engineer. I also participate in pre-sales activity and customer success engagement. My current focus is reliability and performance. So before starting, just a raise of hands, who else has, I'm pretty sure most of you guys know about performance tuning or parameter tuning, especially in your daily rate of time jobs. Who else has actually done with it or have been encountering all these things and doing the performance tuning to make your database faster? Anyone raise your hand? Yeah. So in my day-to-day activity, as I said, I'm part of dbtune, and dbtune stack is growing day by day. We are adding many different services, many platforms, and when we do that, we have developed in-house workloads. We use certain benchmarks like HammerDB's TPCC, like Benchbase, Suite, and whenever we add a new platform, I end up, you know, deploying the workloads and testing those on those managed services. What I do is that I check, okay, the tuning guidelines that have been established while supporting the new platform, does it hold, or what variation it happens when it takes, right? So and when I was doing, I encountered few anomalies. I'm not saying anomalies. I maybe the right word, maybe the challenges. And I thought, why not create the topic around it? It might be interesting. As I said, I'm a DevOps engineer. I'm not a DBA. You guys might be more educational than me. You might know more database about me. I don't. I'll be the first one to admit. So this was like, these experiences were surprising to me, interesting to me, and I thought, why not share it with the community and see if they have also faced those things, and maybe they can learn about it from me as well. So yeah, keeping that in mind, let's get started. I'm going to give you a puzzle. So this is a puzzle. As I was saying, as the dbtune stack grows, we end up applying the workload from one database to another. So here is one same Postgres version database applied on one stack, and same Postgres version applied on a different stack with same workload. Everything is same. A tuning recommendation gave us a configuration that should be performing very well. But what we saw here was that on one Postgres version, we were getting 6 millisecond average query runtime, and on other, we were getting 0.06 millisecond. So that's like 100x difference. Why? Well, because on one, just-in-time compiler was on, and on the other, just JIT was off. So that's the puzzle we are going to solve. Not that the tuning advice or the recommendation wrong, but what happened when infrastructure differs from the assumptions that were made to create those tuning guides, and what to do about it. So that's the premise of the talk. What you will learn today, as I said, I'm not here to prove that the tuning recommendations are wrong. I'm just going to be showing that in the modern world, we live in a world where infrastructure, there are some small tweaks which actually changes those recommendations. So I'm going to present 3 patterns. They can be many. I'm calling these patterns. They can be called as gaps. They can be called as traps even. But for me, pattern sounded a little better. So I'm going to present 3 patterns. Different starting points. Here, this means basically change managed service normally do change defaults. Second is infrastructure changes the math. This is the section where I'm going to show or discuss things like storage, things like compute, things like caching, and when that changes, what happens with the tuning recommendation that you are following. And the third is related to interaction and amplification. This is an interesting section. This is basically when I'm going to talk about that parameters don't work in isolation. And I'm not just going to blabber about the problems. I will try to give you, a framework where you can apply these patterns or the thing how to solve it into your current system. What kind of checklist can you follow? Similarly, what is the data-driven tuning workflow that you can actually adapt to improve your critical thinking? And the tools that actually exist today. So if you use those, you can improve your thinking process. So keeping all that in mind, let's get started with the first pattern. So pattern one is different starting points. We live in a world where things are obviously changing rapidly. You have got many different providers and coming daily. Even the current providers are changing their infrastructure and their default settings. So, for example, if you have applied some recommendation and you come back after a month or 2 months, there is a good chance that the underlying layer has changed. This reminds me, we were in a meetup, Prague meetup, very good meetup that was happening on Saturday, and Joseph, our colleague, was giving a very interesting talk, and he was mentioning the 10 commandments. So you have got now different managed servers that apply those commandments. When I say commandments, as you all know, the default Postgres has like very old defaults. Random page cost set as 4, shared buffers are very small. And he was saying that applying, people do change this and say that this is tuning, but this is not. This is like just old 10 commandments that people are following. So that really resonated with me, and this is what normally these services do. They don't actually, they do change the defaults, and imagine you are following a tuning guide and you don't know about these. You will be blaming the author, or you will be blaming saying what the hell is what's happening with it, right? So this is what we experienced when we were testing our stack. As our stack grows, we just supported Flex Server and the new platforms. And when we apply those settings, we often see these patterns. So I'm in this section, I'm just going to show the examples. I'm not going to debate how you can do it, but I'm just going to mention what kind of examples that we saw. First example that I've just, had an just touched upon was JIT. Just-in-time compiler. If you mostly know that from Postgres 12, it is by default on, which is actually right, because for complex queries, it really can improve the performance. And that's what we were doing. I mean, we recently have been, so RDS has been on our marketplace, and when we were doing the testing, I observed this phenomena. As I mentioned previously, we have certain workloads that we normally test. So we have established a good amount of knowledge base around those workload. So I was testing this on our upstream Postgres self-hosted version, and we knew, okay, this is a tuning guide. This is a recommendation that works for that opinions workload. Opinions is a benchmark, part of Benchbase. You can easily find it, and we tweaked it based on our scenarios. It's a simplistic benchmark, but the point here was that when we applied the same benchmark on RDS, I was baffled. What is happening? Why the good recommendation is not translating to RDS? When we digged deeper, we found out that on RDS, just-in-time compiler is actually off. Why did they do that? Well, they analyzed their workload, their customer workloads, and they realized most of their customers are on OLTP with short queries, with cached queries, and for that specific workload, I'm not saying all of them, but most of their workloads, to disable JIT will be beneficial for their clients, for their customer base. And that is what the different starting point actually means. So imagine you are following a guide, which obviously is going to be Postgres 12 has been like 4 years, 5 years, if I'm not more than that, right? So if you see just-in-time the guides that are available online do assume that, and they don't mention it. This is not a parameter tuning, straightforward parameter which people play around with. So this is somewhat hidden. But if you don't know it, you will be banging like I was doing. I wasted certain amount of hours to seeing what's happening, and then I realized, okay, this was the reason. So that's interesting. Another example is a little subtle, which is related to Aurora. So the assumption Postgres guides made is that planner will behave constantly across environments. But that assumption doesn't hold on Aurora, because Aurora has the optimizer transformation is controlled by Aurora specific parameters. What I mean with that, one example, is that do you know that you can rewrite correlation subqueries into better effective plan by enabling an parameter in Aurora that only exists in Aurora, doesn't exist in RDS, doesn't exist in self-hosted, uh, to get the better simplistic plan, performed plan. And why did they do that? Because Aurora runs on distributed storage. So they were able to do some tweaks based on the parameters that are not available anywhere. So imagine you are following a guide and you have got correlation subqueries which are very heavy, and a guide will say that, okay, please rewrite those type of queries. And you do that, and you end up getting bad performance. So if you don't know about these platform service basic things, or sorry, specific things, things can be difficult. Again, the point here is not that the guide is wrong, not that the parameter is wrong. It's just that you are not starting from the same place. So if you're not starting from the same place, the advantage will be obviously different, and your every decision made after that will be a guesswork rather than educated opinion. Another small example here is related to shared buffers. Again, the 10 commandments, that was the nice word. Sorry if I'm repeating. I'm basically taking that from Joseph. So as we all know, set 20 shared buffers to 25%. This is something that RDS does, and it's a really good thing. Resizing that thing changes the site, but you do know that if you go to Azure, that doesn't happen. Resizing that doesn't do that. Especially in GCP, when we were trying, some SKUs don't do 25%; they do more than 25%. And as I said, they made their decision based on their customer workloads, and they said that, okay, this will probably serve better for their customer workload. So yeah, that's basically pattern one. So what to do about it? It's very simple, honestly. Simply know your baseline. In our part of the world, before doing any tuning or before doing anything, establishing a baseline is very important. And when you're doing this in your home, or applying any tuning recommendation or following any guide, knowing where you start is very important. And you can do that by simply running show all. If you find any difference, compare it with the actual Postgres defaults, find why did they do it. And I know this is very boring, but read provided documentation. I still say that I wasted at least few of my working hours by just not reading the documentation. If I knew that on Aurora they had their own customized optimization, if I knew that JIT is disabled on RDS, I might have saved a couple of days of my working hours, right? And this is very boring stuff. We don't like. At least I don't like. I'm not going to speak for everybody, but I don't really like reading documentations. But every change has intent behind it. Knowing the intent is important. Without knowing it, you will be lost. So in pattern one, we discussed how managed services changes defaults, right? Often changes default. In pattern two, we are going to discuss how infrastructure changes math. That is basically what Postgres obviously make the optimizer make the decision based on the simple math. When infrastructure differs, that planner decision changes. So this is an interesting thing as well, right? Postgres follows a very simple model. It doesn't know about cloud. It doesn't know about your billing method. It doesn't know about your burstable disks or all those things. It simply say, okay, relative cost is reading from disk is heavy, is reading from cache is heavy, heavy, or memory is heavy, and based on that relative math, it will make decisions. How do I understand it in a very simple words? I have hired, you have hired a very over-enthusiastic accountant, and its job is to find the cheapest way to execute a query. It's not going to actually execute it. It's going to make decision based on the price list it has. When I say price list, I'm talking about configuration, the parameters that the configuration hold. And those are actually assumptions. So whatever at that point the configuration holds, it will make a decision. It will not, as I said, will actually execute and see what's happening, but it will, based on the decision, it will define a plan. It will try to avoid reading from the disk because it is assumed that it's going to be hard. But now we live in a modern world where things are, rapidly changing. We have got SSDs, we have got NVMEs, and they are changing rapidly. And in a modern world, reading from disk is actually not really very what you call time consuming. There is still small difference, but it's still not a very big difference that it was used to be. So this section basically covers that. I'm going to share few examples, which I'm going to show you that these in the modern world these things are happening and how you can actually deal with them. First, let's discuss about storage. Most of the tuning guides, like I'm going to give an example for PGTune. It's a very good starting point. I believe everybody knows about PGTune. If you go on PGTune, they ask what kind of workload you have. They ask what kind of disk you have. If you write SSD, they will give you a certain configurations, right? Assumption is the storage, you have got local storage, predictable latency, but now things are different. You are running on cloud, you are running on a Kubernetes cluster of AKS or EKS, etc., where there is a network attached disk, there is a hop, network hop, there is always a latency. So the configuration that you are applying can choose a wrong plan which will not hold here. Similarly, if you are in a cross-region scenario where your workload is coming from another region and your database is hosted on another region, then the network hop is really very big. So even the disk itself is fast. It's still SSD. So the guide is not wrong. Again, the point here is not that the guide is wrong or the parameter is wrong. The point here is that you need to adapt for your own world, right? And I give the world the message of the world here as because planner is not doing something wrong. Postgres is making the decision in a right way, but for the wrong world, right? So that's one thing. The other example which comes to mind is storage variability. Now we have got cloud comes up with another twist. You have got burstable disks as well, where it runs on credits. When the Postgres planner is creating a plan, maybe at that time the storage has got like many credits, but at noon time when the workload spikes, hits, you've got a high TPS, things change, and the certain plan that was currently available is no longer valid. This is something that is we faced recently. We were giving we have supported Azure Flex Server recently, and we were giving the training. I was tasked to prepare an test workshop environment for our attendees. So I was testing this again, and this was not burstable disk. My understanding was that okay, I'm not using burstable disk. I'm using a general purpose disk. But my workload was very heavy, but I was not getting the performance. The thing that I found obviously was, okay, the disk had a cap. So now you have got tiers as well. Even you are using a disk, but there are certain different tiers. Every SKU changes the IOPS limits, your storage capacity limits. And because of the checklist that I follow, I noticed that and then I adapted to it. If you are following a tuning guide and you're not aware of this thing, then you will face the same issue like I was facing. So same parameter, same Postgres version, but different infrastructure because of the variability that storage comes in. This also translates to your parallelism, This also translates to your compute. Compute is basically CPU. Again, Postgres is a very simple. It sees you have got 4 CPUs. It will make a plan for 4 CPUs. If you have got 8 CPUs, you got a plan for, it will create a plan for 8 CPUs. But now you are in a world where things are, you're like running a mobile data plan, which can change at any time. If you get a call from your loved one, you're talking for like 30 minutes, 40 minutes, suddenly you're exhausting your credits, right? So the plan now is that for any emergency call, you will not be able to attend that call, right? Similarly, in the world of Kubernetes, you have got there is a negotiation. You have got a concept of limit and request, right? You do a limit of 4 CPUs, you request 2 CPUs. So if you have a noisy neighbor, so you are running 2 or 3 pods, and you have a noisy neighbor, and he has extracted all the resources. So that actually means the plan was for 4 CPUs, but now you end up with a parallelism paradox, where you have built a door. Sorry, you have launched 4 people, but the door is now for 2. So we live in a world of negotiation. That doesn't mean that the parameter or the plan was not wrong. This simply implies that that there is a variability and things have now changed. So you need to adapt. The point I'm trying to make is this is not one thing which you can simply do one time and say that, okay, why doesn't it work? But because of the variability that exists, we need to adapt from it. Another good example here comes to mind from the same workload, same thing. We are also working on a seats benchmark. I'm not sure if you guys have heard about it, but do look around. Benchbase has got a very good suite, having like 8 to 10 benchmarks that we work with. One of them is seats. It stimulates an airline's ticketing system. It's very fast, 4 millisecond to 6 millisecond of workload, and we were doing this on RDS. On RDS, the optimal tuning recommendation was without parallelism. And we, as I said, because we run it very constantly, we had a very good understanding, okay, this is what this kind of benchmark or this kind of workload should give us. This is the recommendation. But when we supported Ivan is another cloud provider, you must be aware of it. There, the good optimal tuning configuration was with enabling the parallelism. Why? We were just wondering what's happening. Are we making some mistake, or the tuning guide that we are following, is it wrong? What's happening? We found out that, okay, the handshake, obviously, when the parallelism things kicks off, there is obviously a kernel process. Handshake happens. That was much faster in the case of Ivan as compared to RDS. So even the cloud pro, it's not about self-managed or cloud. Even there is a difference between different clouds as well. So you can't simply copy paste one recommendation from one cloud to another cloud and say that, okay, if it's working on a 4 CPU 32 GB or 8 CPU 32 GB RAM, and it should work to another cloud as well. Even the cloud infrastructure between the different providers do things differently related to their architecture. So what to do? It's pretty simple. Try to see if the load is very simple. Don't test on your staging workloads or your unrealistic workloads. Try to stress test this. See the variability. See what happens with the parallel planning when the load is under stress, which we normally usually do. We try to stress it out. We see what happens with the tuning recommendation or the guides that we are following. Are they holding up? Tune for worst case scenario. More often than that, if the thing that is working on worst case scenario will perform better for the best case scenario. There will always be corner cases, but this is somewhat thing that you can do to handle the compute. Another interesting part, which I'm not going to share too much time on, is caching. Postgres has a simple method, as I said. It either knows that things are coming from cache or from disk. And cache, as the 10 commandments, I'm going to repeat myself. You follow effective cache size set to 70% or 75%, if I'm not wrong, shared buffers to 25%. That's the cache that Postgres knows, right? But now you live in a world of different complicated application. You have got application cache as well. You have got different level of OS caches as well. You are in a layered cake scenario where data can come from anywhere. It's like you are running a warehouse, and suddenly your order comes in, which is not in your current warehouse. You will order it from your store from another country, but you don't know you have a regional store right beside you, which has the data already, which you can get easily. So that's cache, and that is depending on the plan that you are making. What to do? That is why the monitoring tools really help. You have got the monitoring tools. Don't tune blindly to read latency. See your cache hit ratio. See what's happening. And if you see that from your monitoring tool, there is very little disk activity, then the easy fix is just to increase your effective cache size. So if your recommendation is saying set effective cache size to 70% on shared buffers to 25%, and you're not getting performance better, just see for your workload what's your data read looks like, what's your monitoring tool is telling you. And if you see that the your disk reads in your monitoring tools are what you call less, then there's a quick fix. Just change from 70 to 80% maybe, and see what happens. In the pattern 2, so in pattern 1, we discussed how managed services are changing the default. In pattern 2, we saw about the infrastructure related stuff, which is compute, storage, and now caching. Let's move on with pattern 3. Now, this is an interesting section. This is something that we mostly challenge with. Interaction and amplification. I'm showing it like a switch here. It's like if you change one knob, it just lights up 5 bubbles, right? So what does that mean? I'm not a musician, but if I start playing a drum, I will just making a noise, right? But it needs to be in harmony. It needs to needs to sound in harmony. So it's like tuning up the band. That's a phrase I really like. If you want to really tune up the band, everything needs to be interact properly. It's like a web. So if you push, if you spider web, if you see, pick up one thread, it can simply throw it. And that's the problem we are actually trying to, we are working on it, and we think we have solved most of it. We are actually majorly working on this side of things. And in this section, I will try to give few examples on how this actually what look like and what can we do about it. Am I going too fast? I hope that it's all good, right? So introduction, as an example, I always give this example. This is related to random page cost, which we saw recently. Uh, Postgres has got their internal thresholds as well. So as I said, go to pgtune, give your disk size, give your configuration. It will often say for SSD, reduce the random page cost. That's a very good advice. Nobody is arguing that. But in a real world scenario with the real world vector where there is internal thresholds as well, there is a very good chance that you lower the random page cost, the effective cache plans changes. A query comes in that can trigger the internal threshold, which can trigger the parallelism, that can also trigger JIT. By the way, I missed one thing. In the caching thing, initially I gave an example of just-in-time compiler, right? This is why the compute, when resources are fighting for the compute, things like JIT behave differently. It's not like that enabling JIT for PG was a wrong decision. It's because of the variability that the parameter don't behave. And that is what the cascade effect is. You have a person is just following one factor and it's triggering multiple things. So as I said, it's a web thing. Everything interacts with together. So every decision can create a different plan. It can trigger one thing and it can obviously enable a different plan, which can dump the performance. And you will be left with thinking that, okay, what's happening and what can we do about it? How do you handle the cascade effect? As I said, don't ask is the parameter good or bad. So if you're following a guide and it's saying that I have reduced the random page cost, why my performance is tanking, or I have reduced any other parameter, and why did it tank? Well, it's not about the parameter. It is what it actually unlocked. It's a cascading effect. Analyze before what run, explain, analyze. See it in your actual workload. See what the plan changes. Here I'm going to give another example which is related to a customer workload. So a customer was running a workload. It has got like a millions of data, big tables, terabyte of data, and everything was working perfectly fine. But once a month, there was a bulk activity, a heavy bulk activity that raises the CPU spikes, which created bloats, which created dead tuples, and the performance was tanking. The question was, if the parameters and performance tuning was done, why was it that it's not performing? After looking into it, we found out that okay, the auto vacuum threshold was actually not triggered. As I was just mentioning beforehand, there are certain thresholds which triggers things, which can trigger JIT, which can trigger parallelism. So auto vacuum threshold was not triggered. Just tweaking that threshold fix the problem, fix the parameters. So it's the point here is you don't need to start blaming the settings that you have or the recommendation that you follow. You need to actually see that how to actually handle it. The next part is statistics. Postgres makes every decision based on the stats, right? It's the snapshot that you have in your database. When you run a query, when you run your database, it develops a statistic model based on it. As I'm going to repeat it, based on that stats, it's going to make the decision of, okay, what kind of join I'm going to use, what's the indexes I'm going to do, and all those things. And that actually implies amplify everything. So if there is a difference of stats in like 5%, things can drastically change. it can be a very downward event. And the amazing part is that it's not immediate. So it's not like I was giving an example of auto vacuum. It was not like an immediate effect. It was observed after 3 weeks because of the variability, and the stats differ. So when the plan was made, the statistics were totally different. But when the issue happened, statistics differ. So you always have to, analyze, explain, and, see what's happening. These are your tools. These are your helping things that can always help you. Look for your smoking gun. When you run explain analyze, see what your estimated rows are and what your actual rows are coming from. This reminds me of another story that we faced regarding our workload of opinions. We were running, I believe, on GCP. So when we were running the same workload on GCP, the plan was very different. We saw that, okay, because of their internal architecture thing, the statistic that was differing, the plan was chosen to be keeping in mind that it will return 4,000 rows. But when we actually ran it, it was only one row. So that is basically your stats. Your stats were actually different, plan were chosen differently, and things got out of hand. So pattern 3 is interesting in a way where small changes. Postgres is complicated. It's not a simple system. It's variable. It has got layer architecture, and it has got delayed effect. It's not like it's an immediate thing. You change, you observe, and then you validate. That's why sometimes tuning sometimes looks random, but it isn't. It's just a matter of understanding things and then making decision. So these were the 3 patterns that I wanted to share. Now the question is how to actually test those things. I have developed a simple checklist that I have already discussed during the session here. One is storage. Make sure before applying any tuning guide, is your disk local? Is it attached? How does it behave under the intense workload? What's happening with your compute? Do you have a bustable compute? Is the plan changing? Run, explain, analyze. What's the actual rows and estimated rows kind of things? What kind of Postgres version are you running? Where are you running? Are you running self-managed? Are you running on a K8 cluster or a Kubernetes cluster where the compute will be negotiable, where there's going to be a difference of compute, where resource will be fighting and you will have noisy neighbors? Then always try, if you're running on a different system, try to check your docs. For example, if you're running on a CNPG operator, they tend to also filter few parameters out. So you should be aware of it, what kind of parameters they are filtering out. And if you're not tuning, or if you're applying a recommendation which is basically via CNPG operator, things can totally be very different. Similarly, workload is very important. And all those things are not a single problem. They work in interaction. It's like a web. You change one, the other is effective as well. So you need to be aware of all these 4 things. Step 2, measure. Always measure. Measure on your own system. Before applying any guide or any recommendation, always measure on your own system. Establish a baseline. Do a change. Measure, decide, and then repeat. It's an iterative loop. Treat it like a science, not a folklore. It's not a one-time thing. Things that you apply or a guide that you apply once a month or even once a quarter is not a right way to do it. It needs to be done because it always changes based on your workload, based on your infrastructure characteristics. Then comes, I used a word, measure, right? But what to measure? Measure your workload. You have got your friends around you. PG stat statement gives you the statistics. You pick your top 5 queries from it. Focus on the top 5 queries. I follow the 80-20 rule. I'm listing here a top 5 queries, and this basically means you're 80% of the query. It can be 500, it can be 50, it can be 5. The idea is focus on the top 80% of your query and analyze your workload. Use explain analyze. See what is the estimated rows are. What are the actual rows? Is the plan changing under the workload? Is it not? And always monitor your infrastructure provider tools. You have got is the IOPS saturating? CPU session. Are you exhausting your credits and things like that? Postgres doesn't see these things. You must. You need to be the eye of this thing. I'm not saying that Postgres is a black box. I'm simply saying that Postgres is not aware of these things, but you are. You know your infrastructure. You need to know and then decide how to actually modify it. That's why I said it's a science. It's not a folklore. Tools that are currently actually available today that are going to be helpful. As I mentioned, PG start statement, explain, analyze. For visualization, use explain.lb.com. Then for the plan changes, if you want to monitor any kind of plan changes, you should look out at PG stats plan. Infrastructure metrics, people are aware of Prometheus, Grafana. If you are on AWS, you have got CloudWatch. On Azure, you have got Azure monitoring. Then you have got a very popular tool called PG Analyze as well. When I talked about starting point, people normally start from PG Tune as well. That's a very good derivation. Try to know your baseline, know where you're starting from. If you don't know where you're starting from, as I said, everything after that can be a guesswork. And for automation, you have dbtune, which you can obviously check it out. We are trying to solve all these things, most of these things, I will not say all, most of the things automatically. So you can, these tool don't replace thinking, they reduce the blind spot. The idea is that having a tool doesn't mean that, okay, everything is sorted and all good. If you don't go with it, the mental model is same. It replaces your thinking, right? I started with a puzzle, presented you with a puzzle that there was a 100x difference. Why that was not a bug or why that was not a puzzle? We saw same Postgres version, we saw same workload, but very different performance. Why this was a different puzzle? Because of these three patterns. You had a different starting point, there was an infrastructure struggling, and then there was an interaction and amplification and everything. What's the good thinking? What good Postgres tuning actually looks like? It's not about memorizing parameters. As I said, it's a complex problem. Postgres is complex. Don't treat it like a little baby that, okay, setting shade buffers to a certain amount of value, reducing random page cost, or changing the threshold of parallelism, or what you call vacuum. Things will be fine. Don't memorize parameter and just build a feedback loop. It's an iterative process. You need to know, understand, and do it repeatedly. Try to follow the checklist that I presented today. Understand your system. Form a hypothesis and change thing, measure, and then decide. The guides that you see on web are built for their specific system. They are not built for your system. You are running your system. So you are prove the guide in your system and made tweaks about it. So yeah, that was it, guys. I tried to finish it on time, I believe. We have got 5 minutes left for question. So if you guys have any questions, please do. Otherwise, we will be around. We have got 3 to 4 people strolling around. Find us. And if you got any questions, we are here to help.